Hello guys, you're welcome to my YouTube channel Mathematics Made Easy. So in today's video we'll be looking into proving by induction. So we want to prove that 9 can divide 10 raised to the power of n minus 1, that is without any remainder. So for all n an element of the set of natural number. So prove that 10 raised to the power of n minus 1 is divisible by 9. So that is what we are asked to do using uh induction. Okay guys, so let's start with the solution. So when you're proving by induction, the first thing is to make use of the base case. Okay, so the base case is when n is equal to 1. So if n is equal to 1, so we are going to have 10 raised to the power of 1 minus 1, which is 9, and then 9 can divide 9. So 9 is divisible by 9, so the base case is satisfied. Then the inductive step. So by the inductive step, we can assume that, or assume true for n is equal to k. Are you getting me now? So we are going to assume that n is equal to k. That is 10 raised to the power of k minus 1 is equal to 9m. So for some m and k, a set of words, natural number. Are you following me now? So we have this. Then let's move on. So after that, so we assume that n is equal to k plus 1. So if n is equal to k plus 1, so just substitute n to be k plus 1. So we are going to have 10 raised to the power of k plus 1, then minus 1. So what you are going to do next, 10 raised to the power of k plus 1 is also 10 raised to the power of k multiplied by 10, then minus 1. So we can write this as this. All right, so what you are going to do next to add 10 and subtract 10. So we add 10 and subtract 10, we are going to have 10 raised to the power of k multiplied by 10 minus 1 plus 10 minus 10. Okay, so then we are going to have, so minus 1 plus 10 will give us 9. So we have 10 raised to the power of k multiplied by 10, then plus 9 minus 10. Okay, then this is going to give us, this is we can bring this negative 10 here. So if we bring this negative 10 here, so we are going to have 10 raised to the power of k multiplied by 10 minus 10 plus 9. Then we can factor out 10 here, so that will be 10 into bracket 10 raised to the power of k. Okay, then minus 1 plus 9. And don't forget that 10 raised to the power of k minus 1 is 9m. So this would be 10 multiply by 9m, then plus 9. So then you can factor out 9. So we factor out 9, you are going to have 9 into bracket 10m plus 1. So that shows that 10 raised to the power of k plus 1 minus 1 is divisible by 9. Okay, so that ends the proof. All right guys, so if you like this kind of video, don't forget to like my video, share, comment, and subscribe. Thank you for watching. Hello guys, you're welcome to my YouTube channel Mathematics Made Easy. So in today's video we'll be looking into proving by induction. So we want to prove that 9 can divide 10 raised to the power of n minus 1, that is without any remainder. So for all n an element of the set of natural number. So prove that 10 raised to the power of n minus 1 is divisible by 9. So that is
Hello viewers, you're welcome to my YouTube channel Mathematics Made Easy. So In today's video, we'll be solving this differential equation. So we have to solve this differential equation. Say solve the equation the y over dx is equal to 2y over x for x is greater than 0 and then y is greater than 0. Okay, so then how are you going to solve this given differential equation? Okay, it's very easy. So we can use the separation of variables in solving this differential equation. So using the separation of variables. All right, so let's dive in. Before I start solving the solution, please don't forget to subscribe to my channel, like my videos, and share. Thank you. Now, let me write out the question. The question says, the y over the x is equal to 2y over x. Then how are you going to solve this question? I've said earlier, say we are using separation of variables. Now we can see the y and we can see 2y, okay? And then here we can see the x and we can see x. So what can we do to bring the x to be here and 2y to be here? And this is what we are going to do. So we can multiply both sides by the x over 2y. Okay, so if you multiply both sides by the x over 2y, then we are going to have the y over the x multiplied by the x over 2y is equal to 2y over x multiplied by the x over 2y. You can see the x is going to cancel the x, and then here 2y will cancel 2y. Then we are going to have the y over 2y, and then this will be equal to the x over x. So it's now easy to solve. Okay, so the next thing is to introduce the integral sign, or the integral symbol. So that's the next step we have to take. So then we are going to have integral the y over 2y is equal to integral the x over x. Now, if we integrate the y over 2y, so what are we going to get? You can see that 2 is a constant, so I can bring out 2. Then I'm going to have 1 over 2 integral dy over y is equal to integral dx over x. Don't forget, integral of dy over y, that's just natural log of y, and integral of dx over x is also natural log of x. So this will be 1 over 2 natural log of y is equal to natural log of x plus c. Okay, then what do you think we can do next? Oh, you can see 2 here, so then we can multiply both sides by 2. Then if we multiply both sides by 2, we are going to have natural log of y is equal to 2 multiplied by natural log of x plus 2c. Okay, then don't forget you want to know the value of y. So if you raise both to the power of e, so that means we are going to have y is equal to e raised to the power of 2 natural log of x plus 2c. Okay, so this will be y is equal to, so e raised to power 2 limits, so that is x squared, and then we have e raised to the power of 2c. Okay, so we can just say let e raised to the power of 2c be capital letter c1. Okay, then we are going to have y is equal to x squared multiplied by c1. So that's
Hello guys, welcome to my YouTube channel, Mathematics Made Easy. So in today's video, we'll be looking into this theorem, the generating function of the harmonic numbers, which is given by the summation of n from 1 to infinity of hn multiplied by x raised to the power of n equals natural log of 1 minus x over x minus 1. So for any absolute value of x is less than 1. So I want to prove this uh, formula, okay? That is the summation of n from 1 to infinity of the harmonic number multiplied by x raised to the power of n is equal to the natural log of 1 minus x over x minus 1. Now, proof. Now, consider the definition of the harmonic number. Let's consider that. So, let's consider the definition of the harmonic numbers. Now, that is, now we know that the harmonic number is equal to hn minus 1 then plus 1 over n. Okay, so hn is equal to hn minus 1 plus 1 over n. So we can subtract hn minus 1 from both sides. So we do that, we're going to have hn minus hn minus 1, so is equal to 1 over n. The next thing I'm going to do here is to multiply both sides by x raised to the power of n. So we multiply both sides by x raised to the power of n, we are going to have hn multiplied by x raised to the power of n minus hn minus 1 multiplied by x raised to the power of n is equal to x raised to the power of n over n. So what you're going to do next is to sum both sides from n equal to 1 to infinity. So summing both sides from n equal to 1 to infinity, so we're going to have sum of n from 1 to infinity of hn x raised to the power of n minus sum of n from 1 to infinity of hn minus 1 x raised to the power of n is equal to sum n is from 1 to infinity of x raised to the power of n over n. Now, if we look at this right hand side sum, so this is the same thing as negative natural log of 1 minus x. Okay, so summation of x raised to the power of n over n, so from 1 to infinity is negative natural log of 1 minus x. So then we are going to have sum of n from 1 to infinity